when scientists saw the pictures, they were shocked. The far side looked completely different than the near side. It's saturated with craters. It just was such a huge dichotomy. Nobody was expecting that at all.
So one of the biggest mysteries in planetary science over the last about 50 years is, why is the crust of the far side so thick?
The moon, a beacon in the night sky, has captivated humanity for millennia. But what mysteries does its hidden face hold? Today, we are going beyond the familiar to explore the dark side of the moon. This lunar landscape, bombarded by meteors for billions of years, is a treasure trove of craters, mountains, and what else? Could there be more to the dark side than meets the eye? Join us as we explore the latest discoveries, lingering theories, and embark on a captivating journey to unveil the moon's best-kept secrets. Debunking the dark side myth. With a little help from binoculars or a telescope, the moon transforms from a distant orb into a world etched with craters and splotches of color. But there is a curious fact about our lunar companion. No matter how you look at it, you're only ever seeing one side. This begs the question, what secrets might lie hidden on the opposite side, the one that perpetually faces away from Earth? The term dark side of the moon often conjures images of a mysterious and unknown land, shrouded in perpetual darkness and facing the vast emptiness of space. It sparks the imagination, leaving us to wonder what wonders or oddities might exist on this unseen side. Perhaps there are alien landscapes bathed in the faint glow of distant stars, or maybe it's a desolate wasteland ravaged by solar winds. However, astronomers tend to wince a little whenever they hear this term used. They understand its popularity. After all, even the legendary Pink Floyd album title made it a cultural touchstone. But the widespread use of dark side also creates a lot of confusion, and here's why. Firstly, the fact that we always see the same lunar face is a consequence of something called tidal locking. We'll delve into that fascinating phenomenon later. But the biggest culprit for the confusion, it all boils down to the terminology itself. So let's unpack this misconception and discover why dark side might not be the most accurate term for the hidden face of the moon. The moon's dual nature. The term dark side throws a bit of a shade, literally and figuratively, on our understanding of the moon. As mentioned before, it paints a picture of a world eternally shrouded in shadow, a stark boundary separating the illuminated side we see from an abyss of perpetual darkness. But this simply isn't the case. While it's true there is always a part of the moon that's not bathed in sunlight, it's not a fixed region. Just like Earth, the moon experiences a day and a night cycle. Imagine yourself as an astronaut stationed on the moon's surface. You wouldn't be stuck in an unending night. You would witness the sun majestically rise above the lunar horizon, casting its light across the landscape before eventually setting and giving way to a starry night sky. Here's the key takeaway. The dark side of the moon isn't truly dark all the time. It's more accurate to think of the moon having a day side and a night side, just like our planet. The day side basks in the sun's glow, while the night side is cloaked in darkness. But here's where things get a little tricky. The side of the moon we see from Earth can sometimes be the day side, and sometimes the night side. It all depends on the specific lunar time when we look up at it. To clear up the confusion, a more precise term exists: the near side and the far side. The near side is the permanent face of the moon that is always pointed towards Earth, regardless of your location on Earth. The far side, as the name suggests, is the opposite side, perpetually facing away from us. Even if you hopped on a plane from New York to Sydney, Australia, just to peek at the moon from the other side of the planet, you would still see the familiar lunar features we've all come to know. Both the near side and the far side experience the dance of day and night. They both get their share of sunlight during the moon's journey around Earth. The crucial point is that we simply can't see the far side, even when it's bathed in sunlight, because it's always turned away from our gaze. So the question remains, what's the reason behind seeing only one side of the moon? We'll explore that fascinating connection next. The force behind the moon's perpetual face. The moon takes about 29 days to complete one full revolution around Earth. And interestingly, it also takes about 29 days for the moon to spin once on its axis. This remarkable coincidence, where the rotation and orbital periods align perfectly, is the key to understanding why we always see the same lunar face. Imagine the moon not spinning on its axis. In that scenario, as it travels around Earth, we would eventually see every side of its surface. But that's not what happens. The culprit behind this synchronized rotation in orbit is a force called tidal locking. Earth's gravity exerts a stronger pull on the side of the moon facing us, and a weaker pull on the far side. This gravitational tug creates a stretching effect, ever so slightly slowing down the moon's rotation over time. Eventually, the moon reached a point where it takes the same amount of time to rotate once as it does to complete one orbit around Earth. In simpler terms, the moon became locked in its position, always presenting the same side to Earth. However, there's a twist. Due to a wobbling motion called libration, we can actually see a little bit more than 50% of the moon's surface over time. Libration allows us to peek around the edges of the near side, occasionally catching glimpses of the far side. But it's important to note that these glimpses are limited. Because of the moon's locked orientation, we can never see the far side directly, head-on. We can only observe it from an angled view, which makes detailed observation quite challenging, unraveling the mysteries of lunar asymmetry. Our journey to the moon has revealed a curious asymmetry. The two sides of our lunar companion look remarkably different. The near side, the familiar face we see from Earth, is dominated by vast, dark plains called Maria, which is Latin for seas. Early astronomers, mistaking these features for bodies of water, gave them their current name. In contrast, the far side presents a heavily cratered and rugged landscape. Here's where the mystery deepens. The near side has 31.2% of its surface covered in Maria, while the far side holds a mere 1%. Scientists have been puzzling over this stark difference for years, and a few fascinating theories have emerged. One theory points to the heat factor. Geochemical maps created using data from lunar missions suggest a higher concentration of heat-producing elements on the near side. These elements could have played a role in volcanic activity, leading to the outpouring of lava that eventually solidified into the Maria. While other factors like surface elevation and crust thickness might influence volcanic eruptions, they don't explain why the far side South Pole Aitken Basin, the moon's lowest point with a thin crust, wasn't as volcanically active as the near side's Oceanus Procellarum. Another intriguing theory proposes a celestial collision. Some scientists suggest the far side's unique appearance might be a consequence of a massive impact with a smaller moon, a leftover from the same collision that is believed to have formed the moon itself. This impact could have created a thick layer of material on the far side, explaining the abundance of craters. However, this theory faces a challenge. The chemical composition of the far side doesn't quite match the expected makeup of such a collision. The crater disparity itself is another interesting observation. Initially, scientists thought the Maria on the near side might be obscuring craters, creating the illusion of a smoother surface. But calculations show that Earth only blocks a tiny portion of the moon's sky, making it an unlikely shield from impacts. The prevailing theory suggests that while both sides likely received a similar number of impacts, the near side's resurfacing by lava flows buried many craters, leaving them unseen. The latest research sheds light on the role of Earth's heat during the moon's formation. It suggests that the near side cooled down slower, leading to a thinner crust. This thinner crust allowed meteoroid impacts to penetrate more easily, triggering volcanic activity and the formation of Maria. In contrast, the far side, cooler due to its position away from Earth, formed a thicker crust earlier. Impacts on the far side would have had a harder time breaching this thicker barrier, resulting in the heavily cratered landscape we see today. Finally, the far side boasts a more dramatic roller coaster ride in terms of elevation. The moon's highest and lowest points, along with its tallest mountains, all reside on this hidden face. This uneven terrain further adds to the moon's fascinating asymmetry, offering scientists a glimpse into the moon's complex geological history. Charting the far side of the moon. Our fascination with the moon's far side goes way back. Before the era of space exploration, it was a realm of pure speculation. Some imagined it as a perpetually frozen and ominous wasteland. The truth, as with most things in science, proved far more captivating. The far side remained a complete mystery until October 1959. That's when the Soviet space program made history with their Luna 3 probe. This ingenious spacecraft managed to swing around the moon, capturing the first ever glimpse of the hidden face. The images, though grainy, revealed a surface dramatically different from the familiar, cratered plains of the near side. The next major leap came in 1962 with NASA's Ranger 4 mission. This probe held the unfortunate distinction of becoming the first human-made object to crash land on the far side. Sadly, a technical glitch prevented it from transmitting any scientific data before impact. The real turning point in mapping the lunar far side arrived with the Lunar Orbiter program. Launched by NASA between 1966 and 1967, this series of uncrewed probes conducted a comprehensive survey of the moon's hidden hemisphere. Lunar Orbiter 5, the final mission in the series, deserves special credit for capturing most of the detailed imagery we have today. However, nothing beats a first-hand view. In December 1968, the Apollo 8 mission achieved just that. As the spacecraft, carrying astronauts Frank Borman, James Lovell, and William Anders, became the first humans to orbit the moon, they were treated to a spectacular sight, the far side in all its glory. Astronaut Anders described it, saying it looked like a sand pile his kids had played in for some time. This was a fitting description for the heavily cratered and seemingly chaotic landscape. Fast forward to the 21st century, and NASA's Lunar Reconnaissance Orbiter continues to explore the moon from lunar orbit. This powerful spacecraft has been beaming back a wealth of data, allowing scientists to create detailed maps of the far side at an unprecedented resolution. One major challenge that plagued early lunar exploration was communication. During the NASA-Soviet space race, landing a probe on the far side seemed like an almost insurmountable task. The reason? The moon itself acts as a giant celestial roadblock, effectively interrupting communication signals between mission control on Earth and any spacecraft on the far side. However, this hurdle was overcome in 2018 by China's space agency. They launched a special communication relay satellite, positioned roughly 40,000 miles beyond the moon. This ingenious satellite acts as a bridge, relaying signals between Earth and spacecraft exploring the far side, paving the way for future missions to this mysterious lunar frontier, China's historic moon landing. In January 2019, China made history by becoming the first nation to land a spacecraft on the far side of the moon. Their Chang'e 4 mission wasn't just a landing, it was a science powerhouse. The mission included a robotic rover named Yutu-2, which carefully disembarked onto the lunar surface. The landing site was far from random. The spacecraft touched down within the vast South Pole Aitken Basin, a colossal depression believed to be the scar of an ancient world-shaking impact. This impact was so powerful that it likely excavated material from the moon's mantle, the layer between the rocky crust and the molten core, and brought it to the surface. For scientists eager to understand the moon's internal composition, the South Pole Aitken Basin is a treasure trove waiting to be explored. One of the first intriguing discoveries made by Yutu-2 was the surprisingly thick layer of soil on the far side. Measurements showed this layer to be 130 feet deep, far exceeding what scientists had expected. This finding adds another piece to the puzzle of the moon's asymmetry. If, as some theories suggest, the near side has a thinner crust that allowed lava to erupt and form the Maria, then the far side's thick soil layer could be a key piece of evidence. However, the big question remains: why is there such a dramatic difference in crust thickness between the two sides of the moon? This is a mystery that continues to challenge our understanding of the moon's formation and evolution. Unveiling the moon's hidden layers. Peering beneath the surface of the moon has always been a challenge, but the Chang'e 4 mission with its Yutu-2 rover is changing that. This robotic explorer is equipped with a powerful tool called Lunar Penetrating Radar. Imagine it as a super-powered echolocation device. The LPR sends out radio signals that dig deep into the lunar surface, and then listens for the echoes bouncing back. These echoes, essentially radio waves reflecting off underground structures, allow scientists to build a map of what lies beneath the moon's dusty exterior. Up until 2023, Yutu-2's LPR had been able to probe the top 40 meters of the lunar soil. This initial survey revealed a fascinating layered landscape. The topmost portion was a jumble of dust, soil, and broken rocks. Nestled within this layer, the LPR detected a hidden crater, likely formed by an ancient impact in the moon's distant past. The debris surrounding this crater, called ejecta by scientists, hinted at the violence of the impact. But the real surprises were waiting deeper down. Beneath the surface layer, scientists discovered not one, but 5 distinct layers of lunar lava. These layers were likely formed billions of years ago, when the moon's interior was much more active. Let's rewind time for a moment. Scientists believe our moon formed about 4.5 billion years ago, shortly after the birth of our solar system. According to the leading theory, a giant object, roughly the size of Mars, collided with Earth. The impact was so powerful that it ripped a chunk of our planet's mantle free, flinging it into space where it eventually coalesced to form the moon. For the next 200 million years or so, the young moon was bombarded by asteroids and comets. These relentless impacts not only scarred the lunar surface, but also cracked its newly formed crust. Much like Earth, the moon's interior at that time contained pockets of molten rock called magma. These cracks provided a pathway for the magma to erupt onto the surface, creating ancient lunar lava flows. The data from U-22's LPR suggests that this volcanic activity wasn't a constant firestorm. The deeper the rover's radar probed, the thinner the lava layers became. This indicates that eruptions became less frequent and less intense over time. In fact, most lunar volcanic activity is thought to have ceased around 1 billion years ago. However, there's a slight wrinkle in this theory. Some evidence suggests there may have been occasional volcanic eruptions as recently as 100 million years ago. Despite these outliers, the moon is generally considered to be geologically dead today. That doesn't mean there isn't still magma lurking deep within the lunar mantle, but large-scale eruptions are likely a thing of the past. Now it's time for today's subscriber pick. The image we are focusing on today has been making the rounds lately, and it's definitely got people talking. It's a collage of 2 photos, side by side. In the first image, we see what looks like a large, dark object with bright lights, contrasting sharply with the moon's cratered surface. The second image zooms in, revealing a complex network of lights that resemble a vast city. The text overlay says, "James Webb Telescope discovers huge structure on the dark side of the moon." Is this real? Or is it just a clever Photoshop job? The James Webb Telescope is powerful, but it's designed to look deep into space, not necessarily at our own moon. So far, there haven't been any official reports of the telescope finding anything like this on the moon. But that hasn't stopped the rumors from swirling. So what do you think? Is this image a sign of something out there? Or is it more likely that it's just a creative hoax? Share your thoughts in the comments below. The hidden granite of Compton-Belkovich. When scientists began probing the far side of the moon, the last thing they expected to find was a colossal chunk of granite buried beneath its surface. This discovery, made by a team of planetary scientists, sheds new light on the moon's volcanic past and challenges our understanding of how granite forms. The research team sifted through a treasure trove of data collected by various lunar missions over the years. They focused on a specific region called Compton-Belkovich, long suspected to be an ancient volcanic complex due to signs of past volcanic activity on the surface. But what truly surprised the scientists wasn't finding evidence of volcanoes. It was the sheer size of a feature hidden beneath Compton-Belkovich. Their analysis revealed a massive deposit of cooled magma, estimated to be 50 kilometers wide. Here is where things get interesting. The data collected by lunar orbiters allowed the team to measure temperatures deep below the surface of Compton-Belkovich. The readings revealed a heat source, unlike any they'd expected. This heat signature pointed towards the presence of radioactive elements. Elements that, on the moon, can only be found in one type of rock: granite. This discovery sparks a fascinating mystery. How did granite form on the moon? On Earth, granite is a common rock, created when large areas of molten rock form beneath the surface due to the combined effects of water and plate tectonics. However, the moon is a desolate world, devoid of both water and plate tectonics. So, the presence of this massive granite deposit challenges our current understanding of how this rock can form. The surprise deepens when we consider the location of this granite. Previously, scientists had only found tiny traces of granite on the near side of the moon, primarily in areas rich in maria. The prevailing theories for granite formation on the moon usually involve processes less common on Earth, such as intense melting caused by a massive impact event. However, the Compton-Belkovich region shows no signs of such a violent event. This discovery on the far side of the moon presents exciting new questions. It hints at the possibility of unique geological processes at play during the moon's volcanic era. Processes that might have differed significantly from what we see on Earth. Further exploration and analysis are needed to unravel the secrets locked away within this hidden lunar granite deposit. The moon, it seems, still has plenty of surprises waiting to be revealed. Illuminating Shackleton Crater. For decades, the far side of the moon has remained largely shrouded in darkness. But a new image from NASA is about to change that narrative, shedding light on a fascinating crater that has never been seen in such detail before. This discovery could even pave the way for the exciting possibility of finding water ice on the moon. The crater in question is named Shackleton. It is a colossal basin formed by a cosmic impact, most likely a speeding comet, 3.6 billion years ago. This titanic collision left its mark on the moon's south pole, carving out a crater that dwarfs even Earth's most impressive canyons. Shackleton boasts a depth 3 times greater than the Grand Canyon, making it a truly awe-inspiring lunar landmark. However, for all its grandeur, Shackleton remained frustratingly out of sight for humanity for a very long time. As we know, the dark side of the moon is tidally locked with Earth, meaning it constantly faces away from us. This made it impossible to get a clear view of the crater bathed in sunlight. However, a revolutionary camera system called ShadowCam is changing the game. This technological marvel, which is on board a South Korean spacecraft, boasts a light sensitivity over 200 times greater than any previous lunar camera, allowing it to see into the perpetual shadows that cloak the far side. ShadowCam achieves this feat by utilizing Earthshine, which is the gentle glow of sunlight reflected off our own planet that bathes the far side of the moon in an ethereal light. Thanks to ShadowCam's ingenuity, we can finally get a good look inside Shackleton Crater. Its location at the moon's south pole is particularly intriguing to scientists. This region is known for its complex geological makeup, making it a prime target for exploration. One of the most exciting aspects of Shackleton is the presence of sunlight on its rim. Due to the crater's shape and position, sunlight falls on the rim in 3 distinct sliver-shaped segments. While previous observations captured the crater's basic outline, they lacked the detail and clarity offered by ShadowCam. The cold temperatures within Shackleton Crater, a bone-chilling -173 degrees Celsius, could also hold the key to a significant discovery. According to NASA, such extreme cold might indicate the presence of water ice. These permanently shadowed regions, or PSRs as they are called by scientists, are known to trap gases that freeze onto their surfaces. The existence of water ice on the moon would be a major breakthrough in our understanding of our lunar neighbor and its potential to harbor resources that could be vital for future exploration. The far side advantage. The far side of the moon presents a unique opportunity for astronomers to place radio telescopes, as it is naturally shielded from Earth's radio transmissions. This isolation makes it an ideal spot for uninterrupted space observations. Small, bowl-shaped craters on the moon's far side could serve as natural foundations for stationary telescopes, similar to the famous Arecibo telescope in Puerto Rico. But for truly grand ambitions, astronomers have their eyes set on a much larger crater, Daedalus. This colossal crater stretches 100 kilometers in diameter and is situated near the center of the far side. The 3-kilometer-high rim of Daedalus acts like a natural shield, effectively blocking stray radio signals from orbiting satellites, ensuring the telescope's observations remain pristine. Another promising candidate is the Saha crater, offering similar advantages for radio telescope placement. However, establishing a radio telescope on the moon isn't a walk in the lunar park. Scientists need to overcome several challenges, one of which is lunar dust. This fine, abrasive powder can wreak havoc on equipment, vehicles, and even spacesuits. Special measures will need to be implemented to shield the telescope's delicate components and ensure the smooth operation of any machinery on the lunar surface. Another hurdle involves protecting the telescope from the fury of the sun. Powerful solar flares can disrupt radio signals, potentially compromising the telescope's observations. The solution lies in a careful selection of materials for the radio dish, ensuring they are adequately shielded against solar flares. Finally, the area surrounding the telescope needs to be meticulously chosen to minimize contamination from other radio sources on the moon, ensuring the telescope can focus on the faint whispers of the cosmos. Speaking of whispers, scientists are particularly interested in a specific location on the far side, the South Pole Aitken Basin. This colossal depression is a scar left behind by a monstrous impact event that carved out a formation nearly 2,400 kilometers wide. The force of this ancient impact is believed to have penetrated deep into the lunar interior. By sending a robotic lander to this region and collecting samples, scientists hope to unlock secrets buried within the moon, providing invaluable insights into its internal composition. The far side of the moon holds another potential treasure: helium-3. This rare isotope of helium is found in much higher concentrations on the lunar surface, particularly in the Maria on the far side, which are less shielded from the solar wind compared to those on the near side. On Earth, helium-3 is scarce, but it has the potential to be a game changer. As a highly desirable fuel for future fusion reactors, a clean and potentially limitless energy source, helium-3 is a compelling reason for space agencies and private companies to consider establishing a lunar base. Such a base could pave the way for a future where humanity harnesses the resources of the moon, ushering in a new era of space exploration and resource utilization. Thanks for watching.